Okay, so last time we said that the derivative of the function f of x at a comma b is the reciprocal of the derivative of the inverse at a comma b, or somewhere else. What did we say in our notes? At b comma a. If we switch the coordinates, because that's the whole point of finding inverses, then the slope will be the reciprocal. Let me give you an example of the types of problems we're going to look at. So to get us started, it is March 3rd. And again, I'd suggest just kind of continuing your notes from yesterday. We put some general information at the top of the page on 5.3. I would just sort of continue from there. These are derivatives of inverses. The first example we're going to look at. F of x equals 1/4 x cubed plus x minus 1. We are going to find f inverse prime of x at x equals 3. I would like to find the derivative of the inverse when x equals 3. First of all, it is not easy to find the inverse of this function. Switch the x and the y, that's not a big deal. X equals 1/4 y cubed plus y minus 1. The tough part's going to be solving that thing for y. That's not going to be the way we go about dealing with these. There's a much easier way than actually finding the inverse and then plugging our 3 into the inverse. Step number 1. I need to go through a little bit of logic to determine the coordinates of some point on the original function and on the inverse function. So I'm going to say step number 1 is determine the coordinates of a point on the original and some point on the inverse. I need to go through a little bit of logic to determine the coordinates of a point on the original and some other point on the inverse. Here's what I mean by this. I'm asking you to find f inverse prime, the derivative of the inverse of x at x equals 3. This x equals 3, this is an x coordinate. This is an x coordinate not on the original, but it is an x coordinate on the inverse. So I'm going to say that. On the inverse, I have the points 3 comma, I don't really know, 3 comma something. Here's where the logic comes in. If I have 3 comma something on the inverse, what point must I have on the original? Something comma 3. On the original function, I have the point something comma 3. I need to figure out that other coordinate. On the original, I have something comma 3. Is 3 an x coordinate or a y coordinate on the original function? Y. So I need to find the x. If you have the y, how would you find the x? Plug into the equation and solve it for x. Okay, so what we need to do to find the x on the original is I'm going to plug in, I'm going to say 1/4 x cubed plus x minus 1 equals 3, and I'm going to solve that. Does that look easy to solve by hand? So what's our rule pretty much in this class? Anytime we have an equation that's not easy to solve by hand, what's the method? Graphing calculator. Take out your graphing calculator, go solve that thing by graphing. So I think we'll add into the notes, we're going to solve that equation by hand if it's easy, by graphing otherwise. And I believe that if you do it properly, you're going to get a nice number answer in this case. Sure, why not? Adela, do you have that missing coordinate? The x-coordinate? X equals 2. Can you get x equals 2? I now know the original function has the coordinates 2, 3. So what are the coordinates of the point on the inverse? Don't think too hard. 3, 2. I now know the complete coordinates. Does anyone need help with the solve by graphing parts? Okay. So that's the beginning of the problem. We're going to go through some logic to figure out coordinates. Basically, I am telling you an x-coordinate on the inverse, which means I've told you, indirectly, a y-coordinate on the original. You need to find the other coordinate by setting the original equal to that number, and then figure out the x value. Number 2. I'm going to find the slope of the original function at the point a comma b, in this case at the point 2, 3. Find the slope, and of course what's another word for slope that's like the real word we're using that starts with a d? Derivative. Oh good. Find the slope, the derivative of the original function f at a comma b, in this case at the point 2, 3. Take a moment, find your derivative. This is completely like normal derivative stuff like we've been doing since September. And you're going to plug in the point from the original, because we're finding the derivative, the slope of the original function. Three-fourths x squared plus 1. And what am I going to plug in? I'm dealing with the derivative of the original. What x value am I plugging in, the 2 or the 3? 2, because I'm dealing with the original thing here. So I'm going to find f prime of 2, the x on the original. I'm going to get 3/4 times 2 squared plus 1. 3/4 times 4, that's 3 plus 1. That gives me 4. I have one more step. The slope of the inverse at b comma a will just be the reciprocal of that thing. Step number 3. The slope of f inverse at the point b comma a is the reciprocal. The slope of the inverse function when x equals 3, because that is the x-coordinate on my inverse, is the reciprocal of what I got over there. It's going to be 1/4. I'm going to give you a function. I'm going to ask you to find the derivative of the inverse at a specific x value. That's an x value on the inverse, which means it's a y value on the original. Find the missing coordinate. Just go through some algebra or solve by graphing. Then we have complete coordinates. Then you're going to find the derivative of the original function at the original point. You can then very quickly find the derivative of the inverse at the inverse point by just taking the reciprocal of the number you got over here. Are you following? I guess the biggest place people kind of get mixed up is the numbers that they're plugging in. The original problem asked you to find f inverse prime of 3. Did we plug in 3 with any of this derivative work? No. The only reason we needed to use 3 was because that was an x on the inverse, so it was a y on the original that helped us find the missing coordinates. We're not plugging in 3 for the derivative work. We're plugging it in earlier to find a missing coordinate. This logic's going to take a little while to kind of sink in. We're going to do a few more of these to make sure we're good with stuff. But this is kind of the basic idea behind this stuff. Let's take a look at one that we're not going to solve by graphing. We're going to do a little bit of work by hand on this one. Let's look at the function f of x equals 1 over x minus 1. And we are going to find f inverse prime of 2. F of x equals 1 over x minus 1. We want to find f inverse prime of 2, the derivative, the slope of the inverse when x equals 2. Question number 1. What is 2? Is 2 an x or is it a y on the original or on the inverse? I guess there are two possible answers to that. But, like, right away, it's an x on the inverse. There are always going to be x's on the inverse. That's what you're being told. So, Lexi, keep going with that logic. If it's an x on the inverse, what else? Y on the original. I'd like you to find the missing coordinate, but I think we can get around solving by graphing on this one. I want you to work by hand to find the x coordinate on the original. So set the original equal to 2. Go through some algebra. And I think it'll be nice enough. Maybe a fraction, but not super horrible. Marley, do you have an answer? 3/2. I'm thinking cross multiply over here, so 2 times x minus 1 equals 1. 2x minus 2 equals 1. 2x equals 3. X equals 3/2. So the original includes the point 3/2, comma 2. The inverse includes the point 2, comma 3/2. Calculus time. We need to find the derivative of that original function. I think you have two options there. I think you could rewrite it and use chain rule, or forget about all that and just go use quotient rule. Doesn't matter. Find your derivative. Bless you. Let's see if I can do something about this. Yeah. Go do a derivative. Raise your hand if you're using quotient rule. Raise your hand if you're using just chain rule. I'm really confused because like 4 of you raise your hand for quotient rule, 4 of you raise your hand for chain rule. There are more than 8 of you here. Well, I'm going to try both and hopefully we'll get the same answer and hopefully you can follow one of them. Chain rule is actually way easier. Well, not way easier, but it's easier. But either way, negative 1 over x minus 1 squared. Okay. What am I plugging into this? 3 halves or 2? 3 halves. This is the derivative of the original. So I need to plug in the x value from the original. That's 3 halves. One over 3 halves minus 1 squared. That's negative 1 over 1 half squared. That's negative 1 over 1/4. I should not have circled that. I'm getting negative 4. What is the derivative of the inverse at x equals 2? It is not 1/4. Negative 1/4. Remember, just reciprocal, not like opposite reciprocal or things like that. Just the reciprocal. Negative 1/4. Are you following? Nod your head if you feel like you're with me and can follow what we're doing. Shake your head no if you're not sold. So where are things starting to go wrong? Or where's my logic kind of breaking down for you?
It's like the negative one.
Okay, so this symbol with all those little things up here means the inverse, the derivative. We are finding the derivative of the inverse at x equals 2. 2 is the x on the inverse, which made it the y on the original. More questions, issues? Okay, then you're going to try this next one on your own. Yep. And then we'll move into one other little thing I want to take a look at today. F of x equals the square root of x cubed plus 2x plus 1. I would like you to find the derivative of the inverse at x equals 2. F inverse prime, the derivative of the inverse at x equals 2. This is not going to be a solve by hand problem. You're going to want to solve this one by graphing to get the other coordinate. See how far you can get on your own with this one. I'm hoping that you started like this. Point on the inverse is 2 comma something. Point on the original is something comma 2. Find the other thing and go start doing some calculus. And the missing coordinate is 1. I hope. Did you use the chain rule when you found the derivative? I really hope you did. You need the chain rule there. Three x squared plus 2 over 2 root x cubed plus 2x plus 1 for the derivative, I believe. Emily Boyce, what should I plug in here? 1 or 2? 1. It's the derivative of the original. We're going to plug in the x from the original. F prime of 1. 3 times 1 squared plus 2 over 2 root 1 plus 2 plus 1. 5 over 2 root 4. 5 over 2 times 2. 5/4. So, the derivative of the inverse at x equals 2 is 4 over 5, the reciprocal. Are you with me on this process? So, every year there is one multiple choice question on AP exam involving derivatives of inverses. Sometimes the questions look something like these. Other times the information is presented a little bit more numerically rather than from formulas, and we have to pick some things out of tables of values. So I'm going to take a look at a couple of these things. I will also say that every year when this shows up, this question, not like from Ashland, but kind of nationwide, has a very, very low percent of people who get it correct. I'm not completely sure why. Let's see what we can do with these things. Part of it is probably the notation. It's just a little bit confusing to kind of read these and know exactly what the question's asking. With that in mind, please read question number 1. Don't do any calculations. Just read the thing. Those of you watching at home, I will scan this sheet and put it on the website so you can download it from there. There we go. That was kind of weird. F and G are differentiable everywhere. G is the inverse of F, and G of 2 is 8, and F prime of 8 is negative 7 halves, and G prime of 2 is what? Nod your head if you're completely confused. Or at least a little confused. Okay. This is nowhere near as complicated as it looks. Here's the deal. Gonna make a little chart here. F, G. I told you that G of 2 equals 8. Therefore, I know the point 2, 8 is a point on what function? G. So let's put that over here. 2, 8 is a point on G. What point's going to be on F? 8, 2, because they're inverses. You know the slope of F at 8, 2. What is the slope of F at 8, 2? Negative 7 halves. Slope means derivative. Therefore, what must the slope be of G at 2, 8? Negative 2 over 7. Do you again follow the logic I'm using here? There is no way I would even attempt these problems without kind of making a little chart of some information. Tell me things about F, tell me things about G. Tell me the coordinates, tell me the slope. Then everything will just kind of fit together. Especially later on when there isn't just like one option for just do the reciprocal of this thing, and we really have to kind of pick out which exact numbers we care about. Like in 3 when we see the table of values in a moment. Number 2, I'm going to set up F and F inverse. I'm going to get some points, and then I'm going to get some slopes. Melissa, can you tell me a point on something? Yeah? Negative 1 comma 7. I told you f of negative 1 equals 7. So that means we have the points negative 1 comma 7 on the original function f. So Sam, what else do we know right away from that? About f prime. Not f prime, but about f inverse.
F inverse is 7 comma 8.
Perfect. Sydney, which slope do I know?
The F prime
Right, so is that the slope of f or f inverse?
F inverse. No,
F. The prime means the derivative, so the derivative of f at negative 1 is what?
5.
So Caitlin Arsenault, what's the slope of the inverse at 7? There we go. Are you following the logic? Okay. Number 3. H of x equals x times g of x. G of x is the inverse. Find h prime of 5. Okay, how do you find the derivative of x times g of x? Don't think about anything we did today. How do we do the derivative of x times g of x? Product rule. Take a moment, do that. Write that out, then plug in 5, then stop, because we're going to have to think about how the plugging in 5 actually works in this problem. X times g prime of x plus g of x times 1. I plugged in my 5, so I just got 5 g prime of 5 plus g of 5. You with me on the product rule stuff? Here's the problem. Can you look at the chart and know things about g right away? No, because the chart's all about f. However, I'm told that f is the inverse of g. So I'm going to start making my own little chart comparing f things and g things and all that stuff. So I'm going to do a little bit of work on the bottom. I have information about f. I have information about g. And then I'll deal with some slopes. What x-coordinate on what function do I care about because of this thing over here? What number should I be focusing on? What was that? X equals 5. On what function? What am I plugging 5 into? The g function. Because of that, I need to say that 5 is an x-coordinate on g. No clue about the y-coordinate. Skip it for now. 5 comma something's a point on g. Caitlin Keaveney, what else do I know right away because of that? About f. Perfect. Something comma 5 is a point on f. I now need to find the missing coordinates. Can I just say, okay, well, when x equals 5, the missing coordinate is going to be 1. Can I just do that? Or am I thinking about this wrong? It's f of x in the chart. Okay. How can I use the chart to get things? Christy, tell me this. Okay. When f of x is 5, when the y value is 5, we need to find the x value. Well, when the y value is 5, the x value is 3. Do you follow that piece? Okay. What is the slope of f at 3 comma 5? Everybody. That was not everybody, but it is 2. The slope of the other one, I'm going to count to 3, and you are all going to say an answer. We can do this. Usually works when we try it this way. You have your answer? Okay. 1, 2, 3. 1 over 2 or 1/2? Yes. Okay. There were two things I needed. I needed g of 5, g prime of 5. What is g of 5? G of 5 means tell me the y-coordinate when you plug 5 in for the x value on g. 3, because of this point that I've created down here. What's g prime of 5? 1/2. What's the slope of g when x equals 5? 1/2. Finish it off. Okay, so 5 times 1/2. So 5 halves plus 6 halves, 11 halves, which isn't showing up, which is 5.5. If you're going to go with letter E. I don't actually think the math is hard here, but the logic gets a little bit tricky. So we just kind of need to just keep everything straight of what's the original, what's the inverse. Flip to the back. There. All right. F and G are differentiable. Okay, F inverse is the inverse function of F. That's nothing too insightful. Write an equation for the line tangent to the graph of the inverse at x equals -1. Okay, forget about like everything from today. What's the equation for a tangent line? No. You know this. Oh, good. Y minus y1 equals m times x minus x1. What do we know right away? x1 is going to be -1. To find my y1, I need to plug -1 into F inverse, which will take a little bit of effort. And to find the slope, I need to plug -1 into the derivative of F inverse. I'm going to start my little chart on the side with some points and some slopes. I know that -1 is an x-coordinate on the inverse, which means that -1 has to be a y-coordinate on the original. I would like to see if you can continue that little chart using the table on the top to find all the values you need, and then see if you can use all that to write the equation of the tangent line. While you are working, stay closely, I'm going to pass out the cumulative review for next week, and also the homework worksheet. The beginning of the homework is nothing like today. It will be just last time with the pre-calc review of the inverses, finding some inverses, and the f of g and x have to equal x stuff. Rest of the homework are the derivatives, either from formulas or from tables of values or other information. And don't quit the sheets. We're working on a way yet. I do want to try to get through a little bit more. I'm trying to make a point with the cumulative review. There's something that I think I need you to memorize. And perhaps if you write it a couple times, you'll memorize those things. Because the time has come to finally notice. It is not the same thing. They go in a different order. You had better get the same answers on the first page, the third page, and the fifth page. Every year I have people with different answers on those pages. Don't let that be you. Yep. What's the missing coordinate in F? Yes. I was basically telling you -1 was an x on the inverse, so it was y on the original. It was a y on the original, so the x that matches up with that is 2. So the one on the inverse is -1, comma 2. On F, 2 comma -1, what's the slope there? 4, because we're looking at the F prime column, so yeah, it's going to be 4. So what's the slope of the inverse? Oh, question, Michael.
On the table, it says the x value of -1 is
Got to be careful between what's F inverse, and what's an x, what's y. Have you figured out what the issue was?
Yes.
What's the slope of the inverse of -1? 1/4, because it's the reciprocal of the other one we got. We're basically there. Y. Okay, hold on. So now my tangent line has to deal with the F inverse stuff. What's the y coordinate I'm going to use? 2. Okay. What's the slope I'm going to use? 1/4. Hold on a sheet. We might look at B and C in class Monday. Maybe, maybe not. I'm not sure. But hold on this. We are going to stop this recording.